Math 3, Unit 4, Section 4. We're going to continue with solving rational equations. We are solving because we have an equal sign. So anytime you have an equal sign, you're actually solving for x. You're getting a value for your variable. Okay, previously we were simplifying equations because we didn't have an equal sign. So all we were doing was simplifying them down. But now we actually get to find an answer. Okay, so there are steps here. The first thing you want to do is find the LCD of the equation. Okay, after that, you are going to multiply every term by the LCD. Once you do that, you will end up being able to solve for your variable. And then the last thing is that you need to check for extraneous solutions. That might be a new word to you, but extraneous solutions are answers that make the denominator of a fraction equal to 0. Okay? So for instance, if I told you that x equaled 2, if we ended up plugging negative 2 into this equation, what's negative 2 plus positive 2? 0, right? Yeah, and anything as a 0 in the denominator is undefined. So you will have extraneous solutions on these problems because you can't make an answer that makes the denominator 0. Okay? The next thing, so as we go through here, the first thing we need to do is solve our equation. And then the second thing we're going to do is state whether each equation has no real solution, one real solution, two real solutions, or infinitely many solutions. Okay? All right. So, step 1, find the LCD. So, I like to, at the top, write what my LCD for the problem is. So, on this first problem, if you're looking at your denominators, what would be my LCD? What would be my common denominator? X plus 2, okay? I also, even though it's like step 4 here, I like to write what my extraneous solutions are, and I just simplify that as EXT. And
mention all AVID members. Your meeting will start at 7:20 in the LNC Annex.
What would make this denominator equal to 0? And you can even look at the LCD. What would make this equal 0? Negative 2, correct? We would set that equal to 0, and that would be a negative 2. So I'm going to write here, x cannot equal negative 2. If you just put negative 2 there, that's also fine. You're saying an extraneous solution is negative 2. I just like to write x cannot equal negative 2 because it reminds me of what an extraneous solution is. It can't equal that value. All right, so step 1 is done, as well as step 4. Step 2, we're going to multiply every term by the LCD. So if you notice, there are only 2 terms here. Do you guys see that? So we're going to multiply this one by x plus 2, and this by x plus 2. Okay, when we do that, the x plus 2's cancel. And we are left with x minus 1. Very good. Equals. Here, x plus 2's also cancel, and we are left with x squared plus 2x minus 3. Now we need to solve for the variable. In order to solve for the variable, our equation needs to be set equal to 0. Okay, we also want our x squared term to be positive. So I'm going to move everything here on the left side to the right side. So that means I'm going to subtract x and add 1 because that would eliminate those, correct? And I have to do the same thing on the other side of the equal sign. So subtract x and add 1. We're keeping our equation balanced. So this eliminates, and I have 0 now on one side. Are we okay with this? Okay, so I have x squared, and notice how I lined these up so they're with like terms. 2x minus x makes x, and negative 3 plus 1 makes negative 2. Your equals 0 could be on the left side, or I can move the equals 0 to the right side. And I personally like it on the right side better. Okay? But it doesn't matter which side it's on. Okay, so how will I solve for x here? What do I need to do? So there's no more like terms because we have x squared x and -2. We're going to factor. You solve for x by factoring here. And so my multiplication number is going to be what? -2, and my adding number is 1. What numbers will work here? -1 and 2. Good. So those multiply to be -2. When you add them together, they make 1. Can I use my shortcut? Yes. So in my parentheses, we are splitting up x squared, which makes what in front of each of the parentheses? X. And then we have a -1 and a +2 equals 0. Okay? The next thing we're going to do is solve each of those. Okay? So when I set x -1 equal to 0, what does it equal? This equals +1. When I set x plus 2 equal to 0, what does it equal? Now, you check to see if any of these answers are an extraneous solution. Do you see how -2 and this -2 match? So -2 cannot be an answer. X cannot equal that. So anytime an extraneous solution matches a solution that you have, you cross it out. So that means, what is my answer? X equals 1. And so we did our solving, we did our first thing. And the second thing is state whether each equation has no solutions, 1 solution, 2 solutions, or infinitely many solutions. So how many solutions is that? 1 solution. Okay, is there anything that I did here that is confusing that you would like me to kind of re-explain and go back to? Okay, then let's do another problem. And if at any point I'm doing something and that doesn't make sense, stop me. Okay, so this one, I have an x -3, which I'm going to put in parentheses to remind myself that that's stuck together. I have an x, and then here I have an x squared minus 3x. My suggestion is to factor out any of the denominators if you can. So that can be factored, the x can't be factored. Can x squared minus 3x be factored? To what? Take out a GCF of x and you're left with x minus 3. So we need to figure out our LCD for this problem. So we know that we need an x minus 3 and we also need a x. So x and x minus 3 is going to be my LCD. Okay, so you're looking at all the denominators and you're figuring out what would be the common denominator based on each of the denominators. Good. Okay. Are we okay with that? All right. Now, what would be my extraneous solutions for this problem? So you would set each of the LCD parts equal to 0. So you see how that's one part? So one extraneous solution would be 0, because you would set that equal to 0. Okay? The other extraneous solution would be 3. So you're setting each of those factors equal to 0, which gives you your extraneous solutions. So therefore, x cannot equal 0 or positive 3. Because that would be your x equals 0, and that would be your x equals 3. Are we good there? Okay. Next step is that we are multiplying the entire equation by our LCD so that it eliminates every single fraction. So instead of writing my LCD one time, I go through and write it next to every single term so I can reduce and get rid of the fractions. Okay? So this first one I'm going to write, and this goes at the top. So I'm multiplying by x times x minus 3 to every single term in the numerator. Okay? So every single term I'm multiplying by my LCD, which is x times x minus 3. We look at the first term. The whole purpose is to eliminate fractions. Do you guys see how the x minus 3's can cancel out? Okay? And then you are left with, very good, x times 6, which makes 6x. Okay? So that's the first fraction taken care of. Can we all see what's happened? Okay? So now we're going to the next one. I'm going to write my minus sign. Okay? And what's going to happen here? The x's cancel out. Now, some of you might want to combine steps together, but for right now, I'm going to write this as negative 6 times x minus 3, and I'm going to go back and distribute later. Okay? Equals. Now, first of all, I factored this right here to be x and x minus 3, so you might want to just cross that out so you don't get confused with both pieces. But what do we notice here? Yeah, these will all cancel out, and what are you left with? 18. Is there anything that I need to go back and talk about? Okay? All right. So because I have this parenthesis, I need to distribute what's ever in front of it, which happens to be negative 6, is going to need to be distributed through that parenthesis. So we have 6x, and then negative 6 times x is? Good. And negative 6 times negative 3 makes a? Positive 18 equals 18. What is 6x minus 6x? 0. These cancel out. Do you guys agree with that? So we end up with 18 equals 18. There isn't even an x right now in the problem. What does it mean when you get a statement that says something like 18 equals 18? Actually, it means infinite or all solutions. If you had had something like 0 equals 18, that does not make a true statement, and so that would be a no solution. So the difference is when you have something that actually does equal each other, that is where, and we normally say all real solutions. You could also put infinitely many solutions. I'm going to go ahead and just write all real solutions because that's what we've been doing this year. Another way to write all real solutions, do you guys remember? It's that like R thing like this. So you could also make that mark, okay? The only thing is it's all real solutions except for what? Very good. So I'm going to put except x cannot equal 0 and 3. Okay? And what that means for the second part is that this is actually infinitely many solutions. I can't spell infinitely. Yeah, there you go. That'd be better. Okay. So even though you're taking out 2, there's still an infinite amount of solutions available. All right. Any questions here? No? Is this okay? All right. So let's go ahead and try another one here. Again, anything with pluses and minuses, I suggest putting parentheses around all of it to remind yourself that those are all stuck together like glue. Okay? Is there any way of making a plus 1 and a minus 1 the same thing? No, because if you factored out a negative here, both of these would be negative, which is not the same as this. Okay, can this be factored? Yes. What is that factor to be? Very good. Okay, so based on everything that we've done right now, what is the LCD for this problem? Very good. A plus 1, a minus 1. Okay, so based on that information, we would set each of those equal to 0. And what would be my extraneous solutions? Very good. A cannot equal 1 or negative 1. When you set that equal to 0, you would get a negative 1. And when you set a minus 1 equal to 0, you would get a positive 1. So 1 and negative 1 are our extraneous solutions. Also, since I factored this denominator, I'm going to go ahead and cross this one out so I don't get confused by it, because a squared minus 1 and a plus 1, a minus 1, those are the same thing, right? Okay, so what is my next step? Good. We're going to multiply every single piece of this problem, every single term, by our LCD. So I am multiplying. I'm going to go through and write a plus 1, a minus 1 next to every single term. Okay, do we have any questions? Genesis and Alexis, do you guys have questions? Okay. All right, what do we notice with the first term here? A plus 1's cancel. Okay, so what's left? Good, so we're going to write that as 2 times a minus 1. Some of you might want to distribute it and skip this step, which is fine. I just want to make sure that I don't mess up. So I'm not going to skip it right now. I'm not going to do 2 things at once. Okay, so this next fraction, what happens? The a minus 1's can cancel out. And I'm left with plus 2 times a plus 1 equals, and on the last one, what happens? They all cancel out, and we're left with 4. Okay, now what do I do? Distribute. 2 times a is? 2a. 2 times negative 1? Negative 2. 2 times a? 2a. 2 times 1? Equals? 4. Okay, so here I notice we have a negative 2 and a positive 2, which means they will cancel out. What is 2a plus 2a? Nope, just 4a, because they're like terms we're adding, we're not multiplying. So just 4a equals 4. And then to solve for a, what would I do next? Divide by 4, very good. And, oops, that's supposed to be a 4. And we end up getting a equals, what's 4 divided by 4? 1. Okay, so once we get an answer, we always check it with our extraneous solutions, and what do you guys notice? It's an extraneous solution, which means we cross it out. It's not an actual solution that will work. So what does that tell us?
No solution.
Very good. No solution. You could also put no real solution, sorry. Or just no solution works. Or you could do the 0 with a line through it. Okay, questions? All right. Next problem. Okay, this is called a composition function. We've been doing these this whole entire year. All this is saying is that wherever we see f of x, we plug in x. If you needed to, you could go through and highlight the f of x's and highlight what you're going to put in there. Okay? So this means right now, if I rewrite this, I'm going to have 1 over what? 3x plus 6 equals, and what's going to be on the other side? X over 3. Is it complicated? No. Does it look complicated here? Good. It might be, but it's not. Okay. So I'm going to put this in parentheses. It has a plus, so that means it's all connected, right? Okay. Can this be factored? Yes. By what? 3. And I'm left with x plus 2. Good. So if I'm making my LCD, What would be the LCD for this problem? 3x plus 2. See how we have a 3 in both of these? And then we also have an x plus 2. And I'm going to go ahead and cross this one out right now because it's in the factored form now. Okay, what's my next thing? Good, we are going to do that, but I would do my extraneous solutions. Okay, so if I set 3 equal to 0, that doesn't make any sense. So that's not an extraneous solution. And then if you set x plus 2 equal to 0, that would give us what? So my only extraneous solution is that x cannot equal -2. And again, the 3 part right there, 3 equals 0, that doesn't even make sense. So your extraneous solutions only come from getting x values, okay? Okay, so now the next thing I'm going to do now is what? Multiply every term by our LCD. So 3 times x plus 2 next to every single term in the problem. Okay, what happens on the first term? Everything cancels out and we're left with a 1 equals. In the second one, what happens? 3 cancels out and we have x times x plus 2. What do I do now? Very good, distribute. Okay, so x times x makes, x times 2 makes, and this equals 1. When you're solving, it always needs to be set equal to 0. So what do I do to make this set equal to 0? Subtract by 1. Okay, so this eliminates. We have x squared plus 2x minus 1 equals 0. How will I solve this? Very good. Factor. So most of the time we would multiply over, and when we multiply we get -1 and our adding number is 2. Well, when you multiply to get 1, you only have the numbers 1 and 1, but we need a -1, correct? Which means one of these has to be negative. So will this work? No. Which is slightly annoying, but it is just the way life is. Okay, so we have to use the quadratic formula, which you guys already know, and you guys could probably sing it to me. But I'm not going to torture you, so I'm just going to write it for you here to the side so that you have it in your notes in case for some reason you forgot it, which is highly unlikely. So x equals -b. You're my favorite student right now. Okay. All right, so there it is for you. Remember that when you're using the quadratic formula, it needs to be in descending order. Your a term is always with the x squared term, your b term is always with the x term, and your c term is always the number that doesn't have a variable with it. So in this case, a is 1, b is 2, and c is -1. We are going to plug this information into our quadratic formula. Notice this is x equals. We are solving for x, but just using the quadratic formula. We are still finding a solution. Okay, so x equals -b would be -2 plus or minus the square root of 2 squared minus 4 times a, which is 1, times c, which is -1, all over 2 times 1. So then I go through and simplify, and 2 squared is 4, and -4 times 1 times -1 makes a, which equals 8, and 2 times 1 is 2. So when I simplify here, I have -2 plus or minus the square root of 8 over 2. Can the square root of 8 be simplified? Yes. It simplifies to be 2 root 2. Is everybody okay with that? Because 8 is actually 2 times 2 times 2, pair of 2s, 2 left over. And so we have negative 2 plus or minus 2 root 2 all over 2. And if you reduce that, because you see how all 3 of those pieces have a 2, they can all reduce to become 1s. And so this answer is x equals negative 1 plus or minus. You could write it as 1 root 2, or you could just put root 2. And it's over 1, so do I need to put it over 1? No. Okay, so this is my answer. How many solutions is that?
1.
Nope.
2.
2. Because one solution is negative 1 plus root 2, and then the other solution is negative 1 minus root 2. I know. Okay, so 2 solutions. Okay, we're going to stop there, but I'm going to tell you what your homework is.